And you can start. Maryam Baghipur from University of Hormozgan, Bandar Abbas, Iran, is going to talk on the Harary energy and second largest reciprocal distance signless Laplacian eigenvalue. Please start.
Okay, thank you for giving me this golden opportunity to have this talk. I'm gonna talk about Harary energy and second largest, the reciprocal distance sinus Laplacian eigenvalue. Several matrices can be associated to a graph, such as agency, distance sinus Laplacian, distance Laplacian matrix, and so on. The spectrum of these matrices give us some information about the structure of the graphs. That's why, the Harary energy is based on reciprocal distance. That's why in this talk, I'm gonna talk about reciprocal distance and reciprocal distance sinus Laplacian. Both of them is related to each other. I will explain in detail. Now we study this in this talk. We study some new lower and upper bound for Harary energy in terms of different graph parameters associated with the structure of the graphs. We also show a relationship between Harary energy and the sum of largest agency eigenvalues. We study some lower and upper bound for second largest. Second largest have attracted more attention by some researchers, and there are a lot of papers for second largest of different metrics. For example, agency, sinus Laplacian. That's why it's studying second largest is really important, especially the relationship between different concepts. In my opinion, relation between different concepts is important and it's really interesting. Let G be a connected graph. In distance matrix and reciprocal distance matrix, and each matrix related to distance matrix, graph G must have to be a connected graph. Distance between U and V, we show the U and V is the length of shortest path between U and V. Transmission for a vertex V, for example, or vertex U, is sum of distance from V to all other vertices. Distance for graph Kn. Excuse me, do you hear my voice?
Yeah, we hear your voice.
Okay.
Sometimes it is unstable, but
okay,
generally we do. Yeah.
For example, for graph Kn on complete graph, the transmission for of order n, the transmission for a vertex is equal to n minus 1. For example, for K5 transmission, and the transmission of the different vertices might be different or equal. If all of them be a constant number, we say the graph is a transmission regular. Is equal similar to degree regular. And another concept is really important, sigma G. The transmission of the graph, this here transmission for a vertex and transmission for graph. The transmission for graph sometimes called Wiener index. In fact, the sum of distance between all unordered pairs of vertex. The transmission of G is, in my master, I got to know different indices. For example, Szeged index, Harary index, Wiener index. And after studying, I realized the connection between a spectrum of graph theory and chemical graphs. For example, for distance matrix, transmission is transmission of G is called Wiener index. In fact, the sum of transmission of the vertex is equal to twice of Wiener index. That's why it's really interesting, the connection between Wiener index and distance. I mean, I will explain this concept in detail later. G distance, we show the distance matrix. Transmission G is the diagonal matrix. You know, the entries of the main diagonal is a transmission of the vertices. Ochiche and Hansen defined the distance sinus Laplacian and distance Laplacian matrix. In fact, based on distance matrix, distance sinus Laplacian is defined transmission graph plus distance matrix. You know, the trace of this matrix, distance sinus Laplacian, I mean, is equal to the sum of transmission vertices. I mean, the trace of this matrix is equal to twice of Wiener index. I mean, the distance sinus Laplacian is to some extent related to Wiener index. And we show some result regarding relationship between this matrix and Wiener index. Another concept is really interesting. Harary matrix. Harary matrix is based on reciprocal distance. You know, as all of the entries on the main diagonal is equal 0, and other entries is equal to inverse distance. I mean 1 over distance between U and V. That's why the trace of this matrix is equal to 0. The reciprocal transmission, you know, the reciprocal is similar transmission is sum of inverse distance between V to all other vertices. You know, the sum of the inverse distance of V to all other vertices is called reciprocal transmission. That's why we, according this concept, we defined reciprocal distance sinus Laplacian matrix is equal to reciprocal distance plus reciprocal transmission. I mean, this matrix is to some extent distance sinus Laplacian, but in here we have reciprocal. You know, it's one of the things really interesting. The trace of this matrix is equal to twice of Harary index. You know, this matrix is related to Harary index. And as I say, reciprocal transmission regular, G is a reciprocal if all of the vertices have a constant, have a reciprocal transmission. I mean equal. I mean be a constant number. That's why we say that G is a reciprocal transmission regular. And one of the important results is related to spectral radius. You know, lambda is the largest eigenvalue. You know, each matrix of order n have n eigenvalues. The largest eigenvalue is called spectral radius. Spectral radius is one of the important eigenvalue, and in especially there are a lot of papers for eigenvalues. In fact, for reciprocal distance sinus Laplacian matrix, lambda, I mean spectral radius, I mean largest eigenvalue of this matrix is greater than 4 Harary index over n, and it is a relation between a spectral radius of this matrix and Harary index. You know, G is a is equality if and only if G is a reciprocal transmission regular. Harary energy is defined. There are a lot of some definition for energy. Now, Harary energy is defined some of the absolute value of reciprocal distance eigenvalue. One of the important results for Harary energy, we obtain a lower bound for Harary energy. It is, in fact, we obtain a lower bound for Harary energy in terms of different graph parameters. For example, n, the order of graph, h, Harary index, and we try to characterize the extremal of graphs. All of you know the extremization of the graph is really important. That's why equality hold if and only if G is isomorphic to K or G isomorphic to a K reciprocal transmission regular of order with three distinct reciprocal distance eigenvalues. Another result is a lower bound for Harary energy encoding Harary index and order maximum reciprocal transmission is one of the, all of the vertices in a graph have reciprocal transmission and reciprocal transmission. And the transmission, in fact, we can write the transmission or reciprocal transmission number in a sequence. The maximum is really important, maximum and minimum. The spectral, there are some relationship between maximum reciprocal transmission and spectral radius and the sum of eigenvalues. That's why we obtain a lower bound encoded in terms of maximum reciprocal, and also we characterize this graph. We obtain some other result and a lower simple, in fact, a simple lower bound for Harary in terms of n and minimum reciprocal transmission degree. We obtain a relationship between Harary energy and the sum of the largest eigenvalue. Let me talk in this way. Reciprocal transmission of each of order n have n eigenvalue. Some of them are positive. The trace of this matrix is what for reciprocal distance sinus and reciprocal distance sinus Laplacian. These matrices are semi-definite, positive semi-definite, and all of the eigenvalue are positive. In this theorem, the T is the eigenvalue, positive eigenvalue. For reciprocal distance, the sum of eigenvalue are negative, and T is the number of eigenvalue that they are positive. We obtain a relationship we prove between Harary energy and sum of T largest adjacency. There are some results, some papers for some of the largest, some of the T or K largest adjacency eigenvalues. That's why here we tried to obtain a relationship between Harary energy and the sum of the T largest adjacency. Another result is a lower and upper bound for Harary in terms of N and M. I mean, then order, and M is the edges, lower and of a diameter 2. In fact, we try to obtain some result for Harary energy in terms of different graph parameters. and maximum reciprocal transmission, minimum reciprocal transmission. And it's really important, the connection between different concepts, for example, between spectrograph theory and chemical graph. Another result for the second largest of reciprocal distance sinus Laplacian matrix. You know, we obtain a simple upper bound for second largest, but it's really important. It has a good proof. You know, upper bound is n minus 2 equality if G is equal to Kn complete graph or Kn minus E. As I said, there are a lot of people for different metrics regarding second largest. Second largest, for example, Kincaid-Dots proved some result, interesting result for second largest of sinus Laplacian matrix. And recently there are some, there probably some result for this concepts. Another result, relationship between second largest and second largest sinus Laplacian eigenvalue. You know, sinus Laplacian eigenvalue, one of the metrics that they are interesting and they are very important. That's why we obtain a relationship between second largest of reciprocal distance and some other concepts. You know, in this theorem, we obtain a relationship between second largest and, you know, second maximum, maximum reciprocal transmission. If we want to work to obtain a result for a spectral radius, you know, a spectral radius, I mean lambda 1, I mean largest eigenvalue, because here we obtain a result for second largest. Probably we have a maximum reciprocal, but here we have a relationship between second largest and second maximum. Second largest of reciprocal distance and second maximum, and T distance between V1 and V2. Another result is, you know, all of the theorem, we try to characterize the extremal graphs, I mean the equality. And now we obtain a new result for the second largest in terms of Harary energy and distance between V1 and V2, especially regarding between Harary energy and reciprocal distance, I mean second largest. Now, and the last, we obtain some a relationship between second largest of reciprocal distance and maximum reciprocal, minimum reciprocal transmission, and second largest of reciprocal distance and reciprocal distance, second largest. You know, to be more exact, reciprocal distance is one of the metrics some of professors work on, for example, Kincaid-Dots, Bourgeois of China. And now we obtain a relationship between second largest of reciprocal and second largest of reciprocal. For diameter 2, you know that if I want to explain about transmission or reciprocal transmission, for some graphs we obtain reciprocal transmission or transmission easily. For example, if a graph of a diameter 2, for example, of a diameter 2 here, for example, or here, diameter 2, you know, the transmission for a vertex, for example, I, The degree, degree is the number of age or incident to the vertex I. The degree, the R, if I want to calculate reciprocal transmission or transmission, the RDI vertices in the RDI vertices in distance 1 and n minus DI minus 1 and distance 2. In fact, we can easily obtain transmission regular and reciprocal transmission for a diameter, for a graph of a diameter 2. And with this fact, we obtain some new result for some of graphs. The graphs is based on distance or the reciprocal distance. And this talk, this talk was about some of my papers. In fact, we obtained some new results for different concepts in spectral graph theory. For example, we worked on Strada index, Gaussian Strada index, some of eigenvalues, some of power eigenvalues, and Harary index, Wiener index, Szeged index. And some of, in one of my papers, we proposed a conjecture for MK, the sum of eigenvalues, and we proved it was hold for the graph of diameter 1 and diameter 2. In fact, I have a different idea for reciprocal transmission and reciprocal distance sinus Laplacian. And most of the time, I try to connect it between different, for example, the relationship between smallest eigenvalues. Now I'm working on this paper. A smaller eigenvalue and different concepts in terms of different graph parameters, because one of the important item is the smallest eigenvalues and or a spirit of for example maximum eigenvalue minus minimum eigenvalues. And that's why we wrote some of my papers in reference. And we obtain some, a spectrum of these matrices give us some information about the spectra. We obtain some spectrum, study some spectrum of graphs obtained by operations, for example, joint, lexicographic, and some of operations. Second largest we for Nikiforov defined generalized agency. Generalized agency. In fact, generalized agency extends the spectral property of agency matrices and sinus Laplacian matrices. And after then, Chi defined the generalized metric distance. In fact, extend the spectral property of distance matrix and distance sinus Laplacian matrix. That's why I worked on generalized distance, generalized agency, and I obtained some new results. Most of the time, we try to improve the recently given bounds. Now thank you for your attention. It's that. If you have any question, I'm ready, happy.